Hi guys, Professor Burns here. We're going to start section 3.3, which is looking at skewed distributions. So remember, previously we looked at symmetric distributions. Now we're going to get into looking at numerical data when the distribution is skewed. And previously we used the mean. So when we looked at symmetric distributions, we used the mean to talk about the center, but now we're going to talk about the median. So in this box here, it says when the distribution of a data set is not symmetric, the mean is no longer the appropriate measure for center. Instead, the median of a data set is literally the middle. It's the middle of the data when the data has been sorted from smallest to largest. Again, you've probably heard this term before. Mean is the numerical average, whereas median is the number directly in the middle when we go from smallest to largest for the data set. The median is the best measure for center when the data set is skewed. The median is nice because it's resistant to outliers, it's resistant to the skewness in the graph, so it gives us a good idea of what the typical value is whenever the data is not symmetric, basically. So a quick example here, it says the histogram below shows the distribution of daily high temperatures for New York from May to September of 1973. About half of the days were above 79, about half of the days were below 79. So what would we call 79 degrees? And I just noticed this says Celsius. I don't think that's the right temperature. Well, I think it probably was supposed to be Fahrenheit. Let me change that, Fahrenheit. Celsius, 79 Celsius would be very, very hot. So what would we call the data value 79 degrees? So in this case, since half of the data is above it and half of the data is below it, that makes 79 our median. So 79's smack in the middle when we go from smallest to largest. Suppose we knew that the mean was 77.88, and again, I think that's in Fahrenheit. Label both the mean and the median, and which do you think is a better measure for the typical value for this distribution? So 79, here's 80, I would say 79 is maybe just below it right there. And then 77.88, not that far, a little bit lower, 77.88, and I definitely didn't leave you a lot of room here. Let me see if I can make this a little neater. Let's see, let's put 79 right there, and then we'll say, I would assume that's 75, so we'll say 77.88 is just below it. Now, I think you could actually make an argument that this is roughly symmetrical, almost symmetrical data. But I think you could also make an argument that this data is left skewed, that your tail is here and then more of your data is above that mean. So if we were to say that this is left skewed, then we would want to go with the median as the better measure for the typical value. So we'll go with the median since the graph is left skewed. And again, I think that's a little subjective here. They're very close, the mean and the median. They're both very close, 77.88 and 79, not that far apart. When the median and the mean are close together like that, that's an indication that the data is actually very close to being symmetric. So I'm gonna put a little asterisk here, and I'm gonna say could argue that the data is symmetric, which means we would use the mean instead because they're very close. But we'll go with the median just to be kind of on the safe side there. Now, what about spread when we have a skewed distribution? So we used the standard deviation previously to measure the spread. So the standard deviation measured spread using the distance away from the mean when we had a symmetric distribution. However, since we're not using the mean, we can't use the standard deviation. Those two things go together. So instead, when we're talking about a skewed distribution, we're going to use something else, and we're going to use something called the IQR. And so let's talk a little more about what we mean by the IQR. So a little bit of terminology before we get to the IQR specifically. So the range, to start off, now I think I used that in a previous video, so we've talked about that a little bit, but the range is literally the difference between the largest and the smallest values in the data set, the highest minus the lowest. The values that divide the data into quarters are called quartiles, and each quartile contains 25% of the data set. So basically, the median splits the data in half. If I split the data into fourths or quarters, I have quartiles. So each quartile contains 25% of the data. The first quartile, we would label it Q1, and that has 25% of the data below it and 75% of the data above it. So I'm going to draw like a sort of a number line here, and I'm going to put the median right in the middle, and then we're going to have my minimum value would be down here, let's say, and my maximum value would be here. The first quartile, Q1, would be here, and then the third quartile, Q3, would be up here. So each of these little subsets contains 25% roughly of the data, okay? So does this make sense, or I hope this makes sense for you, when we say that for Q1, 25% is below, but then 75% is above it. The second quartile, Q2, has 50% of the data below it and 50% above it. Now, we don't usually use the term Q2 because what is that really? That's the median, right? Half below and half above. So really we say the median instead of Q2. And then finally, the third quartile, we use Q3 as the notation. We have 75% of the data below it and 25% of the data above it. So Q3 would be here, and likewise, I hope that makes sense to you, that 75% is below it and 25% is above it. So the IQR, what we're going to use for the measurement for spread when we have a skewed data set, is defined to be it's the middle 50% of the data. So if you think about the picture here, let me see if I can get a different color. The middle 50% of the data would be from here, from here, right there. If I can draw, hold on, let me clean that up a little bit. Literally the middle 50%, like I said. So it'd be from here to here, right? So there's 25 there, and this was 25 here. Okay, so the middle 50% is from here to here. And actually, I left a word out. Let me add a word here to my definition just for completeness. I say it's the middle 50% of the data. What it really is the range of the middle 50%. Okay, so think about that. Range is the high minus the low. So if I want the middle 50% of the data and I want the range, in other words, how far does Q1 to Q3 span, I'm going to do Q3 minus Q1. So if you can remember that definition, that it's the range, the interquartile range, that's where the term comes from, right? The range of that middle 50%, it's going to be Q3 minus Q1. And make a note that this is used to measure the spread when the data is skewed. When the data is skewed. All right, and that's what we're going to use instead of the standard deviation. We're going to use the median for the center and the IQR for the spread. Now I'm going to go ahead and go to 3.4 because it's a very short lesson, and these two kind of go together. But 3.4, they're talking about comparing. So if you were looking at two different distributions, how do we compare those? Okay, so if the distributions were both symmetric, that makes it fairly easy. We can just use the mean and the standard deviation for everything. But if one is skewed and one is symmetric, or they're both skewed, then we're just going to default to the median and the IQR. So a little bit of recall here. Remember this. So the three things we use to describe numerical data: the shape, the center, and the spread. So the shape, if the distribution is symmetric or skewed. The center, if it's symmetric, we'll use the mean. If it's skewed, we'll use the median. And then for the spread, if it's symmetric, we'll use the standard deviation. If it's skewed, then we will instead use the IQR. So our primary goal is to choose a pair of measures that is best suited for the data, and of course that depends on the shape. So when you're looking at the graph, make your decision based on that. So always begin with the graphs and look at the graphs to compare. So if the data is symmetric, if both of them are symmetric, we're going to use the mean to compare and the standard deviation for the spread. If one is symmetric and one is skewed, or they're both skewed, then go ahead and default to the median and the IQR. And that's really it for this little section. We're going to just do some practice in class. We'll do some examples where we're going to compare the data sets. And for most of them, we're going to wind up defaulting to the median and the IQR. So it says blank and blank have large influence on the mean and the standard deviation. So what I'm looking for here is the skewness of a graph and outliers. Those have a large influence on the measurements of the mean and the standard deviation. So for that reason, when we have a skewed graph or we have outliers, we default to the median and the IQR. So the median and the IQR are what we mean when we say resistant to data that is skewed. They stand up better to skewness in the graph and any potential outliers. So we'll stop there. Go ahead and bring your notes to class tomorrow. Make sure you bring a calculator because you'll probably need that a little bit, and I will see you in class.